there's going to be a few little differences here and there, but we should be able to find everything about the same. This is a template that I'm going to be giving you um, with code that was set up for the 873A chip where you have the 883. A lot of the things are going to be about the same, but not everything. So don't copy this word for word. But the things that I want you to put into your program that must be in there is anything that's in the orange, or at the beginning it was green. So all this green stuff, anything in black, don't worry about for now. You will add that in as you learn more and more about programming. So the first thing that we're going to do, I'm going to get rid of this. What you're going to do is you normally have an X symbol here. For some reason mine's not working right, but MPlab IDE. You can also find it on the Mac. It's in the applications, and you'll go to Microchip, MPlab X, MPlab IDE, or on a Windows machine, it should be under Programs. Should be under Programs 86, and then you go in there and find Microchip and the program, or you'll find it on your desktop somewhere. This is what you'll see when you open it up. It's going to be loading in some few modules with it. Once it loads up all the way, we'll be able to make a new project. You might, with all my projects, I put them in the same place. And so in my Dropbox folder, I have programs. So pick programs, and within here I have different things all the different things that I'm doing. So, sorry. Once it's loaded up, you're going to want to go up to Make a New Project. It's this icon right here, or you can go to File, New Project. This is going to go into the Project Wizard, as what they used to call it. Within the Project Wizard, we're going to do a Microchip Embedded standalone project. You're just going to say Next. Next. It's thinking. Okay. Oops, back one. You'll have a device that you're going to select. I'm going to go down to the mid-range 8-bit because we're going to be working with the PIC 16. And this one, you'll want to go down and pick the PIC 16F 883. So PIC 16F 883 is what I've picked. I'm going to say Next. Depending on which programmer you're using, PIC 2 or PIC 3. I'm going to pick the PIC 3 for this example. And then we're going to pick a language that we're going to be using. We're going to do the MPASM, which is for the assembly. And then we'll say Next. Now I want to name this project. I'm going to call it Lab 1A, because you might have multiple programs within one lab. You can browse and tell it where you want to put it. Mine's already in Dropbox, pick programs. It's going to call it the new folder, and I could put it in there. I'm going to say, okay, that's fine, and that's going to be my name. Everything else on here is just fine. So you say finish. It's going to open up this project, and we still have to add a few more things to it before we can program. And you need to do this every time that you set one up. The first thing that we're going to add to this program, this is it keeps a list of all your projects on here. So I'm going to close this project. The first thing I'm going to do is I'm going to add a header to it. I'm going to right click and say add existing item. Within here, I need to go find that existing item. Right now it's put me into the folder that I saved everything, but that doesn't work. So for me, I need to go back to my main hard drive. For if you're on a Windows machine, you'd want to go back to C, and then you'll double click on your C, and then you'll go to Programs. I'm going to go to Applications, and then once you're in your programs, you're going to go scroll down until you find Microchip. Once you're in Microchip, I'm going to do MPlab X, and I'm going to do MPASMX. And for the headers, once I'm in this folder, and it's pretty much the same for Mac or Windows, you're going to go down to the PIC16F 883 again. So I'm going to say select that file. And within my header, you'll see that it's there. I also need to add a linker file. Right now there's nothing in my linker file. So I'm going to go to add existing item. This is the same, as long as you're in the same folder as you left with the header, all you have to do is go to the LKR, which is for linker, double click in there, and scroll down to the 16F883. And this one's actually going to have a _G at the end. Okay. Once I have that, I'm going to go down to my source file and say new assemblyfile.asm. Once I click on that, I'll have a template in here. I'm going to call it lab 1A. It's going to create this in the same folder as the previous one. Just going to say finish. And I'm going to have a new screen up here. I'm going to close a couple things because you won't have any of those yet. Okay, so within the ASM folder, this is where you're going to start typing all the main code out again. So I'm going to start off, the first thing we always want to do is add in our name. And so I'm going to do my semicolon, do a couple equal signs, type in my name, do a few equal signs, because all your programs should have your name on them. The next line I'm going to tab over. I'm going to do all caps locks and do list, and then do a tab, P equals 16 capital F 883 _G. Can't remember if you have to have the _G or not, but we'll go with it for now. Then I need to add in my configuration setup. So I'm going to go up to Window, and I'm going to scroll down to my PIC memory views. Within there, there is going to be a configuration bits. With my configuration bits, it's going to bring up a window down here. And for most everything that you're going to do in this class, you'll want to set up these the same. Now, by default, it isn't what we want. So the first thing that we see is config1 value FFFF with field FOSC, which is for your frequency of your oscillator. It's saying that we're going to put RC crystal in there. Well, we're not. We're going to change it to a high-speed crystal resonant oscillator. and it gives me a little warning down here. I don't really have to worry about that. And as you can see, my value has changed from FFFA now from what it was previous. I'm going to turn off my what they call the watchdog timer. The power up enable bit timer should be off. The master clear pin says RE3 master clear pin function is master clear, and that is what we want. We want to keep that pin as a master clear. Code protect off, data code protect off, brownout we want off, internal external switch over bit we want to turn that off. We want to turn the failsafe off. We want to turn off low programming mode. That's for when you're doing something below 5 volts, but we're not. Brownout at 4 volts is fine, and flash memory self-write enable, we want to have that off. Okay, so if we go back up, we'll see that it's now E0F2. That is the value that we have to put in to tell it what we want to do. So here I'm going to say generate source code to output. And what that's going to do is it's going to write the code for me. If you don't have it on the Windows machine, you'll have to type all this in. But what I'm going to do is I'm going to copy, control copy, and I'm going to paste that in with the include pic16f883.include. That will tell it to go look at the header folder for information. If you double click on the header folder, what this does is it assigns predefined names for your pic. So anytime I use, let's go down to a port name. Port A equals 5, port B equals 6, port C equals 7. If this wasn't here, you would have to type this and code it yourself to use these names within your program. Same with trisses and everything else, and you can see where they've predefined these. Anytime I use RA0, it tells it it's equal to 0. So these names, when the compiler looks at them, it will go represent this number for it so that you don't have to worry about it. Okay, if we go back here, once I have that, that is all my header. I can also add in here what this program is. So I'm going to put a comment, and I'm just going to, within my comment, test program setup. Okay. That's the name of my program. That's what it's going to do. Now, the next thing I want to add in here, semicolon, I'm going to add in the rest of all my green stuff. So this one would be number, define, let's put all this caps, define the port names. And then I leave a few spaces. Kind of keep those the same. I'm going to say end, define, okay, and end it. I want to try to keep all this looking the exact same, all the way across. Just so that it looks pretty and people understand what's going on with my code. Okay.